Hey guys, today we're going to be learning about the product rule for derivatives, and what this basically means is that if you let f of x and g of x be differentiable at x, and you have h of x is equal to g of x, f of x, and that is also differentiable at x, then the derivative of h of x is going to equal g of x f prime of x plus f of x, the derivative of g of x. And what this basically means is, in like simpler terms, is that function 1 times the derivative of function 2 plus function 2 times the derivative of function 1.
Alright, so the first problem is f of x equals the quantity of x minus 1 times the quantity of x squared plus x plus 1. Alright, so we're going to take the derivative of that using the multiplication rule. So f prime of x equals the first times derivative second plus second, running out of room, times the derivative, the first, which is just 1. You simplify that a little bit to 2x squared. Oh, it's my fault. Minus 1 minus x plus x squared plus x plus 1. And that simplifies to 3x squared.
Alright, now for our second problem, we're going to make it a little more difficult and throw some trig into it. So, got another product rule. We got f of x equals sine x times cosine x. So to start off, the derivative of x is sine x times negative sine x, because that's the first times the derivative of the second, then plus cosine x times cosine x again. Alright, now we do some multiplication and some simplifying. So for your final answer, you get negative sine x squared plus cosine x squared. And there you go. There's your answer, and another example of product rule, this time using trig. Alright, for our next example, we're gonna try a problem with some negative exponents in it, and this example is y equals x to the negative second times the quantity 4 plus 3x to the negative third. So we're finding the derivative of this. We get y prime is going to be equal to the first function, x to the negative second, times the derivative of the second function, which is going to equal negative 9x to the negative fourth, plus the derivative of my bad, we're going to do function 2, which is 4 plus 3x to the negative 3, and we're going to multiply that by the derivative of the front part, which is negative 2x to the negative third. And then we simplify this, and we get negative 15x to the negative 6 minus 8x to the negative third. However, we're not done, because the negative exponent, we can, there's a rule that says we can basically move this down, the x to the negative 6 down, and make it a fraction, but we can get rid of the negative exponent. So the answer is actually negative 15 over x to the 6 minus 8x to the negative third. And that is actually our answer. For our last example, which I believe is actually the hardest one we have today, we have the example of f of x is equal to the quantity x plus 8 to the fourth times secant of 3 to the x. And when we do this, from the derivative of f of x, we are going to do the first function. So x plus 8 to the fourth. Now we're going to times by the derivative of the second function, which is secant 3 dx. And with the rule of secant of u, we get the derivative of that is supposed to equal secant of u times tangent of u times the derivative of u. So we get times secant 3 of x tangent 3 of x times 3. Then we take the second function, secant 3 dx, and multiply that by the derivative of the first part. So we get 4x plus 8 to the third. Now we're going to simplify this, and we get x plus 8 to the fourth times 3 secant 3 of x tangent of 3 to the x, my bad, plus secant 3 of x 4x plus 8 to the power of 3. And actually we can simplify this a little bit more by pulling out x plus 8 to the third secant 3 of x. And then when we take that out, we get an inside of what we are left with of 3x plus 8 times the tangent 3 to the x plus, let me put that in, a 4. And that is actually our answer. Alrighty, so I hope after doing 4 problems of various difficulties, you feel that you've got a pretty good understanding of the product rule, and now I hope you can use it on your previous and tests.
Alright, Chase meant to say future test, not previous, so just disregard what he said about that. But, have a good day.